given that x1, and so on, x 2023 are pairwise different, positive real numbers. An equals root of x1, plus so on, plus xn, times 1 over x1, plus so on, plus 1 over xn, is an integer, for n equals 1, and so on, 2023. Prove that a 2023 is greater than or equal to 3034. This is an international mathematical Olympiad problem. It seems hard to prove this. However, we can always start with simple cases. Then we might get some ideas for solving the problem. Clearly, a1 is equal to root of x1 times 1 over x1, which is just 1. Ai plus 1 equals root of x1 plus so on, plus xi plus 1, times 1 over x1, plus so on, plus 1 over xi, plus 1 over xi plus 1. We notice that the radicand equals x1, plus so on, plus xi, times 1 over x1, plus so on, plus 1 over xi, plus 3 other terms. We are given that xi's are greater than 0. So the 3 other terms are all greater than 0. Thus ai plus 1 is greater than ai. Because we are also given that ai's are positive integers. So we have ai plus 1 is greater than or equal to ai plus 1. Then ai plus 2 is greater than or equal to ai plus 1, which is greater than or equal to ai plus 1, which is equal to ai plus 2. That is, ai plus 2 minus ai is greater than or equal to 2. We know that a 2023 can be written as a 2023 minus a 2021 plus a 2021 minus a 2019 plus so on, plus a3 minus a1 plus a1. As we've shown that each difference term is greater than or equal to 2. And there are a total of 1011 difference terms. So we can now write is greater than or equal to 2 times 1011 plus 1, which is 2023. We have proved that a 2023 is greater than or equal to 2023. However, the problem is to prove that a 2023 is greater than or equal to 3034. 3034 is 1011 more than 2023. This implies that if we can prove that ai plus 2 minus ai is greater than or equal to 3, then a 2023 is greater than or equal to 3 times 1011 plus 1, which is 3034. Next we need to prove that ai plus 2 minus ai is greater than or equal to 3. We know that ai plus 2 squared equals x1, plus so on, plus xi plus 1, plus xi plus 2, times 1 over x1, plus so on, plus 1 over xi, plus 1 over xi plus 1, plus 1 over xi plus 2, which is equal to x1, plus so on, plus xi, times 1 over x1, plus so on, plus 1 over xi, plus xi plus 1, plus xi plus 2, times 1 over xi plus 1, plus 1 over xi plus 2, plus x1, plus so on, plus xi, times 1 over xi plus 1, plus 1 over xi plus 2, plus xi plus 1, plus xi plus 2, times 1 over x1, plus so on, plus 1 over xi. We know that the term underlined in red is just equal to ai squared. The second term doesn't change. So keep the second term. And the terms underlined in blue is the sum of two terms. By AMGM, we know that the arithmetic mean is greater than or equal to the geometric mean. That is, y1 plus y2 is greater than or equal to 2 times root of y1 times y2. By applying this, the terms underlined in blue is greater than or equal to 2 times root of x1 plus so on, plus xi, times 1 over xi plus 1, plus 1 over xi plus 2, times xi plus 1, plus xi plus 2, times 1 over x1, plus so on, plus 1 over xi. We know that, items underlined in red in the radicand is just equal to, ai squared. So the radical can be written as, ai, times root of, xi plus 1, plus xi plus 2, times 1 over xi plus 1, plus 1 over xi plus 2. So far we have proved that ai plus 2 squared is greater than or equal to ai squared plus xi plus 1, plus xi plus 2, times 1 over xi plus 1, plus 1 over xi plus 2, plus 2 times ai, times root of, xi plus 1, plus xi plus 2, times 1 over xi plus 1, plus 1 over xi plus 2. Note that inequality 1 contains the term underlined in red. So inequality 1 can be further simplified by simplifying the term underlined in red. Xi plus 1, plus xi plus 2, times 1 over xi plus 1, plus 1 over xi plus 2 is equal to xi plus 1, plus xi plus 2 all squared, over xi plus 1, times xi plus 2. Xi plus 1, plus xi plus 2 all squared equals xi plus 1 squared, plus xi plus 2 squared, plus 2 times xi plus 1, times xi plus 2. Again, by AMGM, we know that y1 plus y2 is greater than or equal to 2 times root of y1 times y2. Note that the equality holds if and only if y1 equals y2. As we are given that xi's are pairwise different, so xi plus 1 doesn't equal xi plus 2. Therefore, xi plus 1 squared, plus xi plus 2 squared is greater than 2 times xi plus 1, times xi plus 2. So the numerator is greater than 4 times xi plus 1, times xi plus 2. Thus the term underlined in red is greater than 4. Then inequality 1 becomes ai plus 2 squared is greater than ai squared, plus 4 times ai, plus 4. Which is equal to ai, plus 2 all squared. As ai's are positive integers. So we have ai plus 2 is greater than or equal to ai, plus 3. As we know that a 2023 can be written as 1011 difference terms plus a1. And we've shown that each difference term is greater than or equal to 3. So a 2023 is greater than or equal to 3 times 1011, plus 1. Which is 3034. The proof is complete now.